Hi everyone, I'm Goldie and I'm here to make coding concepts easy to understand. In this video, we are going to be going over the AP CSP pseudocode and specifically the conditionals aspect of the pseudocode. So we're going to cover if, we're going to cover else if, and we're going to cover the else statement. And all of these are going to allow us to make decisions in our program based on different situations. So if you're ready to jump into the material today, go ahead and take out some notes and let's get started together. In this lesson, we are going to go through a lot of information. Not only are we going to talk about conditionals, which is our if and our if-else statements in our program, we are also going to be talking about comparison operators and Boolean operators as well. So there's going to be a lot of new information that we're going to get into, and we're going to cover all of it in the realm of the AP CSP pseudocode, which means this is the code that you are going to see on the AP exam. And it's also pseudocode to help you start understanding all of these concepts that are present in many different computer languages. So let's go ahead and get into it. We're going to first start off with comparison operators. Now, comparison operators, or you'll see them as symbols, are used in programming to form what we call Boolean expressions. So we've talked about Boolean before. A Boolean is an expression that is going to result in true or false. Okay, so when we use a comparison operator, it's going to result in a true or a false statement. And then it's reported to the program because of that. Now, your comparison operators you have seen before in math class in general, in life, we use these comparison operators a lot. So the pseudocode, it's going to look just like we are used to seeing. So the first one is the less than symbol. So for example, if we say 3 less than 5. Now in our programming language, we use a comparison operator to ask a question. The question in this example being, is 3 less than 5? And it's going to result in a true or false. So I ask you the question, is 3 less than 5? That is true. So this comparison operator results in a Boolean expression of true. There's the greater than symbol. Okay, so for instance, is 3 greater than 5? That would evaluate to false. So when you start seeing these comparison operators, we are using them to ask a question. We have the less than or equal to. Is 4 less than or equal to 1? That is false. The greater than or equal to. Is 5 greater than or equal to 5? That is true, right? Because it's greater than or equal to. And then of course we have the equal to. Is 4 equal to 5? That would be false. And then the not equal to. Is 4 not equal to 5? That is true. So we start using these comparison operators in our code to begin to ask questions. So for these comparison operators, we're going to be using mostly integers to compare them. Okay? So here's some simple practice problems of this. What is displayed after the code is executed? So my age starts off as 17 on this first line of code here. And then my next line of code says result gets the value of my age less than 17. Now, when you start having expressions in your code, the expression on the right is always evaluated first. And then that result gets stored into the variable on the left, right? So that's what that arrow means in the pseudocode. It gets stored into that value. So it asks the question, is my age less than 17? Is the value stored in my age less than 17? The answer is false. Right? 17 is not less than 17. They're equal, but they are not less than each other. So 17 less than 17, the answer is false. So that's a Boolean expression that's going to then get stored in the variable result. So when I go down here to my third line of code and I display result, well, the word false got stored into result. So I display result, I am displaying the word false to the screen. Okay. Here's another one. X is 20, Y is 25. And then I ask the question, is X less than or equal to Y? So in other words, is 20 less than or equal to 25. Okay, so that question, is that true or is that false? The answer is true. So that means result is going to be true. Okay, so result right here, this is going to be true. Now our next line of code is X greater than Y. So is 20 greater than 25, true or false? That would be false. So that means that other result, my other variable here, is going to get the word false stored in it. Okay. So when I come down here and I display result and then I display other result, I'm going to display true first and then I'm going to display false. Okay. Because this expression was true, so that's what I display here. And then this expression was false, and that's what I display here, is the variable stored in other result. Okay? So those comparison operators ask questions. Now, comparison operators can also be included with expressions, mathematical expressions. And we don't get too crazy on the CSP exam, but when you have a mixture of operators and comparison operators, so operators being like plus, minus, multiply, divide, when you have a mixture of them, you always evaluate the operators first. So you always do the math first, and you always evaluate the comparison operator last. Okay, so let's look at this first example here. I have 7 minus 4 less than 6. So I have a minus sign and a less than sign. Now, which one do I do first? There's no parentheses. The order of operations, when you do have a mixture of operations, you always do the operators in accordance with PEMDAS first. Okay? And then your comparison operators are always last. So you always ask that comparison question last. So here, I'm going to be doing the subtraction first. Okay? And the subtraction first is going to be 7 minus 4, which is 3. And then 3 less than 6. So now that I'm down to just the comparison operator, I ask the question, is 3 less than 6? That would evaluate to true. So this whole expression evaluates to true. So do the operator first and then the comparison operator. In this one, the next one, 3 times 5 greater than or equal to 16. I do the 3 times 5 first, which is going to be 15. And then now that I'm just left with the comparison operator, is 15 greater than or equal to 16? That would be false. Okay. And then my last example here, I actually have 3. I have division, I have not equal to, and I have multiplication. Okay. So you have 2 operators. You have the 12 divided by 4, and then you have the 3 times the 3. And in the pseudocode, you are going to evaluate those operators first. So 12 divided by 4 is going to be 3. And then 3 times 3 is 9. Okay. So evaluate each of those first. And then the comparison is always done last. So is 3 not equal to 9? That's true. 3 is not equal to 9. That's a true statement. Okay. Here's an example of what you might see when you're tracing, right? So if again, my age is 17, and now I have result. What's going to get stored in result? It's going to be my age plus 21 less than 39. So the value that's stored in my age is 17. I add 21 less than or equal to 39. A mixture of operators and comparisons. So you do the operator first, you take the 17 plus the 21 to get 38, and then you ask the question, is 38 less than or equal to 39? That is true. And because that's true, true gets stored in result, and then you display results, so you display the word true. Okay. Here it is in block code, just some block code. X is 20, Y is 25. Y gets the previous value of Y and subtracts 5. Okay, so when I reach this line of code, Y is 25, and then I subtract 5 to give me 20, and that new value is stored in Y. So that's why I crossed off 25 and it became 20. And then when I get down here, I have a comparison inside of parentheses. And my comparison here asks the question, is X equal to Y? Does 20 equal 20? Okay. Is 20 equal to 20? That is true. So what gets displayed is true because 20 equals 20. Okay. So that's the basic rundown of comparisons and comparison operators and just regular operators when you start mixing. Now, one thing to be aware of in the pseudocode, this equal to is considered a comparison operator. Okay? It's asking the question, is X equal to Y in this case? In most other programming languages, the equal to is an assignment statement. Okay? The equal to acts as the arrow in almost every other programming language. Okay? So if you see that when we start moving to our other programming language, just know that that is a difference between the pseudocode and the language we are using. Okay? If that single equal sign in regular programming language is an assignment, just like the arrow is in pseudocode. Okay. What we would use for comparison in other programming languages is usually the symbol equal to. Okay. And we'll start talking about that when we get into our programming languages. Okay. Now let's talk about conditionals. After all, the notes is called conditional, so it makes sense. We got to talk about these conditionals. There's two types of conditionals we're going to cover in the pseudocode. There's many more, well, maybe not many more, but there's enough more in other programming languages that are usually unique to the programming language themselves. We're just going to get into two types of conditionals. Okay. Conditional statements, what they are, they run a chunk of code only when a certain condition is met. And conditional statements allow a program to be more flexible because they can change depending on different conditions. And this is why we use conditionals. This is why this is the first structure, I guess, we are learning, because we've done sequencing, right? How code runs from top to bottom in order. But conditionals help us ask a question in our program, right? And they evaluate different a series of statements depending on if the answer to that question is true or false. So here is our first conditional. We use the term if. So we ask if, and then in parentheses, we put a specific thing happens. Then in our block of code, then this will happen. Okay? So this is just trying to put into words what a conditional is. We're going to have the keyword if, and then it's going to ask a question. Okay? It's going to ask a question because computers, they are very stupid and they can only respond to a question. So a question can be given in a few different forms that we're going to see, but it's going to ask a question. Okay? If this question evaluates to true, okay, like, yeah, that question, that is true, that's correct, then this will happen. Okay? Then the statements inside of this block, okay, we call this a block, then those statements will run. Okay? Now this block, you have an open curly bracket here and a closed curly bracket here, each on its own line to signal the block. What happens inside this block? It might be one line of code or it might be a couple lines of code. Okay? But that, if this question is true, this will happen. Okay? So the if statement is followed by that block of code, which is the statements inside the curly brackets. And that code will only execute if the expression inside the parentheses evaluates to true. Okay? If the expression evaluates to false, okay? So if this question it asks, if the specific thing, if it answers false, okay, then what happens? Well, then this will be skipped. Then it won't happen. Okay? So now we are able to skip certain segments of code based on if a condition is true or false. If it's true, then I want to run the code. If it's false, I don't want to run the code. Okay? You can have a different action happen if your condition is false. You don't always have to have it. Sometimes you just want it to be, if it's false, you just want the code segment to skip, and that's it. But if you want another code segment to run if it's false, we do that using what's called an else statement. Okay? And this is what they look like together. So here's our if statement. If a specific thing happens, so if this evaluates to true, we are going to have this happen. Okay? If this evaluates to false, then this different thing will happen. Okay? And that's given in the else statement, again, with its own block. So you see the else statement also has its open and closed bracket, its own block. Okay? So this is the question. And we're going to see plenty of examples of how we ask questions here, usually with a comparison operator. This is a question that is going to evaluate to true or false. Okay? If it's true, the stuff in the if bracket will run. If it's false, the stuff in the else brackets will run. Okay? We use these statements in our program when we need to ask a question. Okay? When we need to ask a question. And if the answer is yes, then I want to communicate a specific set of instructions to the computer. And if it's no, I want to communicate a different set of instructions. Okay? So I ask a question, the computer answers true or false, and based on that answer, the segment will run. Okay. From the AP CSP exam reference sheet, so the formula sheet you're given on the exam, these are what those two conditionals are going to look like. So you can just have a plain if statement. Okay. If and then condition, run the block of statements. And this is what it looks like as block code. Or you can have an if-else statement. Okay. An if-else statement. If the condition is true, we just said this runs. If the condition is false, then we said this runs. And then an example of what that looks like in your block code as well. So these are the two conditionals that we are going to cover on the CSP exam and that we're going to be working with and tracing through. Other programming languages have additional conditionals. Like in Python, you can see the if, the elif, and the else. There's also statements like switch statements, etc. Other languages have them. We are just going to be covering these two in the notes and in our practice today. So speaking of practice, here's one practice problem we have. What is display after the code is executed? Okay. So in this situation, we have gas gallons and gallons needed. So just based on those descriptions, what I have here is 10.5 gallons of gas in my car. And how many gallons do I need to get to my destination? That's going to be 12. Okay. So if I were to ask you, say, hey, I have 10.5 gallons in my car, but I need 12 to get to my location. Will I make it? Will I make it? And you'll tell me, no, you won't make it, Mrs. G, because you don't have enough gallons in your car to make it. Now, that's just a conversation me and you can have, but how do I give that series of instructions to a computer so that they print off, oh, you're going to make it, or no, you're not going to make it? Okay, that's where the if statement comes in. So the question is, do I have enough gallons to get where I need to go? How can I ask that question in a computer language? I can use a comparison operator. Okay, I ask the question, is the gas gallons that I have greater than the gallons that I need? Right? So do I have more gallons than I need? And I do that with a comparison operator. Now, if this evaluates to true, right? If I have more gas in my tank than I need, then I want to say, hey, you can make it, right? Take that journey, you can make it. But if this is false, if I don't have enough gallons in my tank, I want to print off like, hey, you cannot make it, right? So this is where the question comes in. Now in my example here, I have 10.5 gallons and I need 12. So which statement is going to print off? Okay. Which statement is going to print off? It asks the question, is 10.5 greater than 12? That's false. Okay. And because it's false, you're going to run the else statement. You cannot make it. Very unfortunate. I cannot make it. Okay. But because it was false, I skipped this line of code entirely. This never ran. I skipped that block, and because it was false, I jumped straight to my else statement and I ran what was in my else statement. Okay, here's another practice problem. Again, what is displayed after the code is executed? So here, x is 20, y is 10, And then I ask a question. So I see this question in here. It has an expression in it as well. I have my if statement and then my else statement. My display down here is outside of the brackets. So when I'm looking at my if and my else statement, I'm just looking at this pair right here. Okay. So the question is x divided by y greater than or equal to 2. And I'm sorry, I put the greater than or equal to, but it's the same as this. In most programming languages, because we don't have this greater than or equal to symbol on our keyboard, instead we use greater than or equal to in our programming languages. So if you accidentally see that in some of my code that I write, just know that it means the same thing. You're still saying greater than or equal to. Okay. So is 20 divided by 10 greater than or equal to 2? Okay. Well, we have to evaluate that expression first. 20 divided by 10 is going to be 2. Okay. So the question is 2 greater than or equal to 2? And that's true, right? It's not greater than, but it is equal to, right? 2 is equal to 2. It is true. And because it's true, we run what is inside the if block and we skip the else. Okay. So because it's true, we are going to run this right here. And we are going to skip this else statement. Okay? The else statement only runs if that expression was false, and it's not. So we skip it. We only run that statement inside, which says 25 gets stored in x. So we change this from a 20 to a 25. And then my last line of code here that runs is display the value of x, which is going to be 25, because that's what's stored in my variable. Okay, now we're going to step up our question game and we're going to start asking multiple questions. And this is where a new type of operator called a Boolean operator is going to come into play. Okay, and Boolean operators help us ask multiple questions at the same time. So let me do this as an example. Okay, consider the situation where your mom will only let you go to the movies with your friends if you have a ride and you take your younger sister. Okay, so think about the language there for a second. Your mom says, hey, you can only go to the movies, you got to have a ride, and you have to take your younger sister. Under which combination of situations will you be allowed to go to the movies? Okay, well, it says if you have a ride and you take your sister, you are going to say, yes, you can go to the movies. Okay. So if this is true, again, our if statements, you can go to the movie. If this is false, you cannot go to the movie. Okay. So that's how we set up our if-else statement. Now this word and, okay, this word and is going to be a Boolean operator. So which of the following situations will you be able to go to the movies? Okay. Well, if it's true, like, hey, I do have a ride, and true, okay, I'll take my sister, right? If both of those are true, is your mom going to let you go to the movies? Yeah, she is. You can go to the movies, okay? You can go to the movies, which means that ride, we're looking at ride and sister, right? If both of them are true, then yes, you can go to the movies. The whole thing's a true statement. Now, let's say the next situation, like, yeah, I have a ride. My friends are going to pick me up, but I'm not going to take my little sister. Okay. So if I say, hey, mom, I do have a ride, but I'm not going to take my sister, what is your mom going to say? She's going to say, no, you can't go to the movies, right? I don't care if you have a ride. You have to take her, you have to have a ride, and you have to have your sister. Other situation like, hey, I don't have a ride to the movie theaters, mom, but I will take my sister. What would that situation what would that outcome of that situation be? She would again say, you can't go to the movies, right? I told you have to have a ride and you have to have your sister. Both have to be true. So in the situation where you're like, I don't have a ride and I'm definitely not taking my sister, your mom's still not going to let you go to the movies. Okay. So why did we do this? Well, it's the keyword and. Okay. When we talk about the and, the only way you were able to go to the movies is if both of those conditions were true. Okay. Ride was true and sister was true. Then you were able to go to the movies. Okay. So keep that in mind. Let's look at the next situation. Let's say your mom's a little bit more lenient and she says, okay, I'll only let you go to the movies if you have a ride or if you take your younger sister. Okay? So the situation here, a ride or you take your sister. So if it's true, then yeah, you can go to the movies. Okay? But if it's false, you will not be able to go to the movies. So again, that language, that or, so we're switching it up. We're not doing and now, we're doing or. So let's look at these situations again from the standpoint of or. So if I say, hey mom, I have a ride, and I'm going to take my sister. Okay. What will your mom say to that? Like, I have a ride and I'll take my sister. Well, she'll say, yeah, you can go to the movies. That's perfect. Right? Now, if you say, I have a ride, my friends are going to pick me up, but I'm not taking my sister, will your mom still let you go? Because she said, if you have a ride or if you take your sister. In this situation, you will be able to go to the movies, right? With that or. Because she said, have a ride or you can take your sister. One or the other. Or we just saw you can have both be true. So in this situation, this next one, if I don't have a ride, but I'll take my sister. I'll be nice. I'll take her. I just don't have a ride. Your mom said or. So you will be able to go to the movies under that situation. But if you say, Mom, I don't have a ride and I'm definitely not taking my sister, both of those are false. Will your mom let you go? No. She will not let you go to the movies in that situation. Okay. Now, why did I do this example of riding and sisters and all of this? It is to introduce this concept of and or. Okay. In order to check multiple conditions, like in our situation there, it was ride and sister. Those were two conditions. In order to check multiple conditions in one statement, you need to combine the Boolean expressions with a single conditional statement. And that's called a compound conditional when we have all of those Boolean expressions. And we use a logical operator to combine them. And the ones we are going to go through in our CSP course, as well as our programming courses, and, or, and not. Those are the three. There's a few additional logical operators, but we don't get into them in the introductory course. Okay, so let's explore these logical operators using the truth table. We kind of already explored the and the or using ride and sister. Now we're going to put them a little bit more formally in a truth table, what's called a truth table. And a truth table is a table that shows the outcomes of all possible logical combinations. And it's a way to help us organize all of those possible logical outcomes. And truth tables are going to be the way that we evaluate some of these longer Boolean expressions, longer compound conditionals, in a way that's going to help us in the long run. Okay. So here, I have another situation. Okay. Again, A and B are going to be variables. A is going to be I am wearing jeans, and B is I play a sport. So these are going to be statements that are either going to evaluate to true or false. Okay? So I set up my truth table, and A could be true and B could be true. That's one combination, right? I am wearing jeans and I play a sport. Now, if I said in class, okay, I want you to stand up if you are wearing jeans and you play a sport. If you are wearing jeans and you play a sport, stand up. And you look around, who is standing? It's the people who play a sport and are wearing jeans at the moment. So we say that's true, that expression. When A and B are true, who stands up? It's the people who are wearing jeans and playing a sport. Both of them have to be true in order for you to have been standing up. Okay. Now, the next situation is A is true, but B is false. So the next combination, yes, you're wearing jeans, but you don't play a sport. Okay. So A and B. So if you're wearing jeans and you're playing a sport, are those people standing up? Is there anyone who has jeans on and they don't play a sport? No, it would be false. Okay. Same thing here. False, you're not wearing jeans, but true, you are playing a sport. Okay. But those people aren't standing up at the moment. Okay. The only people standing up right now are people who are wearing jeans and playing a sport. And then the last combination, you don't wear jeans, you're not playing a sport. Those people are also not standing up. Okay. So this is a truth table. Okay, so you see the table, truth table. It takes all combinations of my two situations of A and B, of my two variables. A can be true or false, and B can be true or false, and it takes all those combinations. Now, when we use that and, we're talking about A and B both being true. Okay. Now let's look at an or. Okay, same situation, A and B, true and true. Okay. Now, if I say in the class, I want you to stand up if you are wearing jeans or you play a sport. Okay. Or you're playing a sport, and you look around the room. Okay. If both of these things are true, is that person standing up? Okay. Is that person standing up? And they are. Okay. The next combination, if someone's wearing jeans, but they don't play a sport, is that person standing up? Because I said, hey, if you're wearing jeans or you play a sport, stand up. Is that person standing up? They are. Okay. I said or, which means only one of them have to be true. They both can be true, but only one of them has to be true in order for you to have been standing up in the class. What if you are not wearing jeans, but you do play a sport? Okay. Is that person standing up? And they are. Because of my language, I said or. And then last, if they don't wear jeans, or they're currently not wearing jeans, and they're not playing a sport, are they standing up? No. Okay. The only people sitting down in the situation are people who are not wearing jeans and do not play a sport. So this is a truth table, again, for A or B. So this time, A and B, all the combinations. Notice how it's the same as it was for the and that'll always be true, those combinations. But now we compare A or B. All right. And then the last one is the not. Okay. So not A, if A is true, and true meaning I am wearing jeans, what would be not A? Well, not A logically is I am not wearing jeans. So what the not does, is it flips it from true to false. Okay? So if A is true, not A would be false. Okay? If A is false, right, I'm not wearing jeans, what would saying I am not wearing jeans mean? Isn't that awkward? I am not wearing jeans. Well, if you're not wearing jeans, then you are wearing jeans, right? You have a double negative, which is actually a positive. If that example is confusing, I don't blame you. Not just means that you are switching the Boolean expression, right? So if it's true, not true is false. If it's false, not false is going to be true. Okay. So the not just switches it. Okay. Not just switches it. Oh, man. Okay. All of those. What does that actually do for me? Okay. Let's just look at some basic comparison operators here. Okay. What is displayed after the code is executed? Just to kind of get our feet wet with a couple of these. Okay. Look at what I have over here. There's a lot going on here. I just learned about conditionals, Mrs. G. What are you doing to me? Because I see a lot of conditionals. What's happening? You have an if statement here. You have an if statement here, an if statement here, and then an else statement right here. Okay. So what does that mean? That means that this single if statement, if this is true, you run this code. Okay. If this is false, you skip the code, and because it doesn't have another else statement that comes after it, if it's false, all you do is just skip the code. Okay. There's an else statement down here, but only time if and else statements are paired together is when the else comes directly after the if statement. Okay. So even this one, this is an if statement. If this is true, then this will run. If it's false, it's skipped and nothing happens. We move on to the next one. This is where they are partnered up. Okay. In order for an if and an else statement to be partnered, they'd have to come one right after the other like this. Okay. So they are partnered up here. So this is saying if this is true, this statement is going to run. But if it's false, this statement is going to run. Okay. So that's what's happening in my code. All right. Now the questions that they are asking includes these new Boolean operators, the and or the or. So I'm going to get to that in a moment. But I need you to understand kind of how the flow of this if and this if-else statement is going to be working, okay? If it's just a single if statement and there's not an else right after it, then it's just asking a question. If it's true, the code will run. If it's false, it just gets skipped, okay? So let's get into what it's asking here. So we'll start off with this question. If 2 less than 3 and 4 greater than 5, okay? So we have 2 comparisons, 2 less than 3, 4 greater than 5. And then in the middle, we have that Boolean comparison. All right, so what happens, we evaluate our comparison operators first. So 2 less than 3, that's true. 2 is less than 3. Is 4 greater than 5? That's false. Okay. So ask those 2 questions first, and then you use the Boolean operator here. Okay, true and false. So think back to our truth table, right? Jeans, like yes, I'm wearing jeans, but no, I don't play a sport. Was I standing with the and? I was not. Okay, it evaluates to false. In order for an and to evaluate to true, both conditions have to be true. Or you can think about the ride and sister example, right? Yeah, like, yes, mom, I had a ride, but I'm not going to bring my sister. Your mom would not let you go to the movies. She said both have to be true in order for you to go to the movies. So this whole thing evaluates to false. Okay? Now in the if statement, if it evaluates to false, what happens? This is skipped. This doesn't occur, and we move on to the next if statement, okay? Because there was no else statement that was paired with it, I don't have a code segment that runs. I just skip it and I move on to the next thing, okay? So that's what happens when you have those single if statements. Now, what about this one, okay? Is 2 not equal to 5? That's true. And then I have, is 3 equal to 5? Okay, 3 equal to 5, that's false. 3 is not equal to 5. So what I have is I'm comparing true or false. Okay. Now remember for your ors, when does your or evaluate to true? Well, your or evaluates to true as long as one or both of them are true. Okay? As long as you got a single true statement in there, your or will evaluate to true. Okay. So this whole thing is true, which means that the code inside of that if statement does run. Okay. So what would get displayed? B would get displayed. I'm going to write that off at the very end here. So I'm going to put a little arrow saying, yes, B does get displayed here. It is not skipped. My last one, okay, it's partnered up because it has an if and an else right after it. So 5 less than 2, that is false. Is 3 greater than or equal to 3? That is true. Okay. So now I have a false or true. Okay. So what will that evaluate to? Okay. Well, because it's an or, as long as one of them is true, the whole thing is true. And when the whole thing is true, that means I'm going to run the code inside of my if statement, and I'm going to skip the code in my else statement. Okay. So what will get printed after the code is executed? BC. Okay. B got printed and then C got printed. All right. All right, one more practice problem here. Okay. What is displayed after the code is executed? Oh my gosh, look at all of this. Okay. If you want to try it on your own, feel free. This is the first time we're seeing some of this crazy stuff. So let's just give an overview of what this code is doing before we trace through it, okay? Because it's just going to require a trace. But I want to try to get organized here because I see something new that I haven't seen yet before. Well, first I see I have a partner here. I have an if and an else statement partnered up. Perfect. Okay. I also see an if and an else statement partnered up here. But inside this if statement, I see another if else partnered up. Yikes. Okay, what is that? That is called a nested if statement or a nested conditional, meaning I have an outer one. This is my outer one right here. And then I have another one nested inside. Okay, so it's a way to kind of ask ask a question. Again, a question inside of another question. Okay. Let me trace through and I'll show you how this works. Okay. So F is 45, P is 5. Okay. F is 45, P is 5. And in my question here, look at this craziness. Okay. Look at how great that looks. I have an operator division. I have comparison greater than. I have an and. I have an operator in subtraction, and I have a less than. I have a lot going on. Okay. Now, the way you evaluate this, okay, you split up on either side of that and you evaluate each expression first. Okay. So this F divided by P greater than 8, okay, F is 45, P is 5. So I'm going to take 45 divided by 5 and ask, is that greater than 8, right? So 45 divided by 5 is what, 9? Hopefully I don't mess that up. Oof. And then I ask the question, is 9 greater than 8? That's true. Okay. My next question on this side, okay, F minus P, so 45 minus 5 less than 50. Okay. So 45 minus 5 is 40. Is that less than 50? Okay. That is true as well. Yay. Both of these statements are true. Okay. So with that and, I do the and last. Okay. Evaluate each expression on either side. I get true and true. And then use the and. What does true and true evaluate to? Well, with the and, the only time an and statement is true is when both of them are true. So this whole thing is going to evaluate to true. Ooh, that was quite the experience. That is as complicated as they get, though. It's not going to get much crazier than that on the exam. Okay, this is an introductory course, right? We don't get too crazy, hopefully. Nope, that's as crazy as it gets. When you have your operators, comparisons, and your Boolean operators, it gets all exciting in there. So take it step by step. We figured out that whole thing is going to be true. So remember, if the whole thing is true, that means this statement will run. And because this is an else, that means this statement is going to get skipped. Okay. So I'm going to display first, and I'm going to skip that else statement. Okay. Now let's go on to the next pair. Okay. Now this whole thing, okay, this whole thing is the pair. This if is paired with this else. I know that this if is paired with this else. Now, how do I know that? It's because of the indents. Okay. Indenting is very important in programming languages. Some programming languages, if you don't indent, your code will not work correctly. In other programming languages, indenting is just a way to help keep things organized, but not required for the program to run. Now, you guys, as good programmers, you guys are always going to indent correctly. Okay, we're going to drill that into you from here out. So the reason we want to indent correctly is because of situations like this, where you have a lot going on, but those indents help keep things organized. So I know that this if is paired with this else because of they're indented on the same level. I know that this if is paired with this else because they're indents into the same level. Okay, that's how you can tell. Now I'm going to start off with this first fun, exciting, joyful expression. Okay. I got operators, comparison operators, and Boolean operators all up in there. So I'm going to draw it out. I have my or right here in the middle. Okay. I'm going to figure that out last. My first step is to figure out this. Okay. This is F plus P less than 50. So F 45 plus P, which is 5, less than or equal to 50. 45 plus 5 is 50. So the question is 50 less than or equal to 50? Ah, that's true. Yay. Okay. We love that. What about the other one? F times P less than 10. Okay. 45 times 5 less than 10. Oh gosh, 45 times 5. Is that 225? Oh, it is. Yay. 225. I got nervous. I had to switch ahead to this slide. I don't want to embarrass myself. 225. 45 times 5 is 225. Is that less than 10? No, that's false. Right? So this first statement was true. This second statement was false. I like the exclamation points because it makes me happy. So now that I have both of those, now I look at the or, okay? Because those were on either side of my or. Now I ask the question, true or false. What does that evaluate to? Okay, well, for an or, the whole thing is true as long as one or both are true. Okay? So the whole thing does evaluate to true here. Yay. Now, because that whole thing evaluates to true, okay, that means that inside of my if statement here, this is going to run, okay, and my else statement is going to get skipped. Okay, so I'm going to move inside. Okay, everything inside that if block. Now, when I look in here, this nested conditional, it's asking another question. Okay, so I get to ask another question. This one isn't as crazy. Is f less than 50 and p greater than 0? Okay, so f less than 50. Is 45 less than 50? That would be true. And is 5 greater than 0? That is also true. Both of these are true. So then the and part right here, okay, true and true. What does true and true evaluate to? That's going to be true. So I'm going to display third and skip fourth, okay? Because this whole thing evaluated to true, I display third and skip fourth. Yes. And what gets printed at the very end, because it wants to know what displayed after the code is executed, first and third were the ones that got displayed there. Okay. We'll have a lot more practice with this. Again, just kind of introducing you to these ideas in the set of notes. I want to finish this set of notes with actually 2 new concepts. The first one is actually a new operator called mod. Okay? MOD is what it's going to look like in the pseudocode. MOD stands for mod or modulus, and it's the remainder that is left after a number is divided by another number. Okay? So you got to think back to when you did like long division in back in elementary school. Okay, so if I have 17 mod 5, what does that even mean? It means take 17, divide it by 5, and what's the remainder? Okay, so take 17 and divide it by 5. Okay, so if you remember, and I'll just do this kind of once here, 17 divided by 5, when you were in, what was it, like 3rd grade or 4th grade, remember you set up division problems like this, and it said, how many times did 5 fit into 17? Well, 5 goes into 17 3 times, right? 5, 10, 15. So 3 times 5 is 15. Okay. Remember, you would take 17 minus 15 to get 2. And there's no other number to bring down. 5 doesn't go into 2, so you brought up the 2. And remember, you used to write R2. Okay, I promise you did this, but it was so long ago, right? So 3 remainder 2, meaning 5 goes into 17 3 times completely, but then you have 2 left over. Now, the mod operator is interested in what this number is. Okay, so 17 divided by 5. Oh, look, I did it over here. Oh, that's so nice of me. 17 divided by 5, you go through and you do that. You get 3 remainder 2. So the answer is going to be 2. Okay, 17 mod 5, the answer is 2. Okay, that's what the mod is interested in. Let's look at this next one. 10 mod 6. So 10 divided by 6. Okay. If you need to do the long division to help you, I mean, go for it, right? 6 goes into 10 once, and then you get 4 left over, okay? You get 1 remainder 4. 1 remainder 4, so that means the mod is going to be 4. 10 mod 6 is 4. All right. 3 divided by 6, okay? So that means 6 going into 3. How many times does 6 go into 3? Well, no times, right? 0 times. which means it goes in 0 times. You still have 3 left over. So 3 mod 6 is going to be 3. Okay. Takes some getting used to, but I promise it'll be good. 23 mod 2. 2 goes into 23 11 times with a remainder of 1. So the answer would be 1. 14 mod 3. You take 14 divided by 3. 3 goes into 14 4 times, right? So 3, 6, 9, 12. So it goes in 12. And then 14 minus 12 is going to be 2 with a remainder of 2. This last one, 0 divided by 2, is just 0 with no remainder. Anytime there's a 0 right here, the answer is going to be 0. Okay. You'll never have a 0 here because you can't divide by 0, right? 0 can be divided by something. 0 divided by something is just 0, but you'll never have a 0 here. It would be technically undefined. And this is as crazy as the mod gets. You're not going to be dealing with very large numbers on the CSP exam. You won't be dealing with negatives, no decimals, anything like that. Just being able to do these basic examples by hand. Now, when is this useful? We will use it in our programming languages. A common usage is to determine if a number is even or odd. If you divide any number by 2 and there's no remainder, the number is even. Okay? If you divide a number by 2 and there is a remainder, then the number is odd. You can also use it to determine if one number is divisible by another number. Again, we'll have a few applications when we get to our programming language. The last thing I want to talk about is unique to the CSP exam, and it's called the random function or the random procedure. Now, computers generate random numbers very quickly, and many programming languages have code already created so that you can do that. We use an abstraction in the pseudocode called random that allows us to randomly generate an integer between 2 values. Okay? So remember, an abstraction in programming, we'll talk about it more in our procedures lesson, but an abstraction in programming means that you can use it without worrying the details about how it's done. Okay? You don't have to worry about those details. Just know that, hey, if I use this random feature, I'm going to get a random number between X and Y. Right, whatever those are. I don't need to know how I got that random number, but I know that I will. And that's what an abstraction deals with. So the pseudocode says random, and then it uses open and close parentheses with 2 values, 2 numbers. And it will randomly generate an integer from A to B, including A and B. Okay? So for example, if I have this in my code, random 4, 8, that means that the number 4, 5, 6, 7, or 8 could be chosen. And the way you see this in a program, it might be saying here, random, using the random number generator to generate that random number and store it in a variable X. Okay? And we'll see examples in our homework and go over some more examples later on that actually use this. So I want to introduce it here and explain what it means. And that wraps up today's lesson on conditionals in the AP CSP pseudocode. Thank you guys so much for watching and following along. If you liked this video, please hit the like button and subscribe to my YouTube channel for more great CS content. Until then, keep coding, keep learning, and I will see you in the next video.